right, so back to the grind. Hope you enjoyed that brief intermission because that's the only one you're getting. So, if we look at these functions, this is first reviewing dance moves. All right, so that was like the very first thing. It's like the very front of your packet. Okay, so that's the bounce, the cross, and the wiggle. You guys kind of ringing a bell with that? All right. So, first things first, we're just going to review how to get the roots from the graph and how to write in factor form. Okay. So, first things first, let's identify the roots. Okay. So, tell me one root, Dylan L. -1's one of them. What's the other one? 4. Now, those are our roots. We also need to figure out the end behavior. What I mean by that is based off of the end behavior, we need to figure out if it's a positive odd, positive even, negative even. So, remember the chord sort that we did? That's what I'm talking about. So, let's talk about this real quick. So, if I'm talking about an odd function, are the tails going to be going in opposite directions or the same direction? Opposite. What about even?
Same.
So even same. So if I have a negative even function, what direction are the tails facing if they face the same direction? If it's a negative even, they're going down. So positive, they're going up. Now, odd, it's a matter of does it look like it's increasing or does it look like it's decreasing? If it looks like it's increasing, like it starts low and then it gets high at the end, then it's positive. If it starts high and gets low, it's a negative. Okay? So, first off, for letter A, you think it's going to be an odd or even function? It's odd because the tails are going in opposite directions. We're looking at these tails. Now, our leading coefficient, so the A value, you think it's going to be positive or negative? Positive. So, guys, another way you can remember it for odd, because I know sometimes it confuses people. If you drew like this a straight line from the end of the first tail to the end of the second tail, that's a terrible line. But if it looks like a positive slope, it's positive. If you go the opposite way, if it looks like it's decreasing or a negative slope, it's a negative odd function. That's another way you can remember it. Because evens are easy because if it's up, it's going up, it's down, it's going down. All right, or negative, whatever. Anyway, so we got our roots, which is -1 and 4, and we know that's going to be an odd positive A function. So it means our degree is going to be an odd number. So the highest exponent should be an odd number. And that's if we put it in standard form. So what would be my first factor? So the -1 written as a factor, Lainey. So -1 written as a factor, what would it be? X something 1. There you go. So the first factor is x plus 1. Remember, this is where you would flip the signs. What about the second factor, Tyreek?
X minus 4.
Good. Now we need to look at the dance moves to determine what exponents are connected to them. So, for -1, what dance move, bounce, cross, or wiggle, do you think it's going to be, Julian? So there's a bounce, cross, or wiggle at -1. Bounce. What exponent is connected to that? It is 2. Yeah. So this will be square. I have music teachers for parents, so the ears are pretty easy. So. All right. What about x minus 4? Is that going to be a bounce, cross, or wiggle, Skylar? So does it look like it's kind of going, or does it look like it's just going right?
No, it's going straight
Yeah, it's a cross. So exponent's going to be 1 for that. Now, here's the way you can remember it, guys. Okay? It's okay if you don't remember it. So typically the exponent for a cross is 1. It's always 1. Well, what type of function has a degree of 1? What type of function has a degree of 1? Starts with an L. Linear. Well, if you drew a line going through the x-axis as a cross, what does that look like? Looks like a linear graph. All right. A bounce typically has an exponent of 2. What type of function has a degree of 2? Starts with a Q. Quadratic. Cubic starts with a C, sir. So if I drew it like this, the bounce actually looks like a parabola. So it's a quadratic graph. Okay. Now the wiggle looks like this typically. It typically has an exponent of a 3, and it's a cubic graph. So this is also a cubic graph. All right. So that's a way that you can remember it as well. If it looks like it's a quadratic graph, it's a bounce, meaning it has an exponent of 2. It looks like it's linear, it's 1. It looks like it's cubic, it's a 3. That kind of just got it. All right. So that being said, we have that part of the function. Now, we're not done because I want to find my a value, or what's going to go right here. Now, you don't need to write that because I'm just going to use this placeholder. So, what can I use? So this is 3.2. What can I use to find the a value? I need at least one what? Close.
Number?
Point. Yep. You need at least 1 point. So 1 point in this case would be the easiest one to find is always the y-intercept. And it's actually the easiest one to calculate too. So this y-intercept, we're going to say it's -5. Now, how do I use that point to find the a value? Plug in for x and y. So you got to plug in the x and the y values of the points in for x and y of your function. So this would be -5 is equal to a times 0 plus 1 squared times 0 minus 4. Well, what's 0 plus 1? 1. What's 1 squared? 1. So this would be -5 is equal to a times 1. What's 0 minus 4? -4. Multiply those together, get -5 is equal to -4a. Divide both sides by -4. A is equal to 5/4. Now, if I plug the 5/4 here, does that also fit the fact that it has to be a positive function? So is my a value positive? Yes. So that fits that part. Now, our degree has to be odd. Is my degree odd? Yes, technically it is. Because remember, the degree comes from its standard form. Another way you can think about it is the number of roots. So if you have an x plus 1 squared, what does that mean for this root? It's counted what? Twice. So if it's counted twice, 1, 2, 3. You have 3 roots, so the degree has to be 3. All right. We count the x plus 1 twice because that's squared, and then the x minus 4 once. So 3 roots, we have a degree of 3, that's odd. Does everyone understand that? All right, let's do one more in this section. So same thing we just did. All right, we're going to figure out if it's an odd or even function, and then whether the a value is going to be positive or negative. So what do you think? Is it odd or even? Dylan P. Let's look at the tails. Are they going in the same direction or opposite directions? So if it's same direction, then it's even. Now, Dylan, do you think it's going to be a positive or negative even function? So is it going up or down? The tails. Down. So that means it's good. So it's an even with a negative a value. And again, we get that from the two tails. They're going in the same direction and they're going downwards. Now, what are my three roots, Layla? Good. All right. What are those three roots written as a factor, Caden? So what's -1 written as a factor? As a factor. So remember, we're writing it as x plus or minus some number. And we're typically switching the signs. So what would that be as a factor? -1 is a factor. So x, there you go. So this is x plus 1. What about for 2, Caden? Good. What's the last one? So for 4. Backwards. There you go. All right. Now we got to focus on dance moves. So what will my dance move be for -1 Wyatt? Yep. What's the dance move? Cross, wiggle, bounce. So cross. So it has an exponent of what? 1. Good. So we don't put anything next to the x plus 1. What about for 2, Wyatt? Can you name them all? Like bounce, cross, wiggle.
Would it be a cross?
It's still a cross. Yeah. So still exponent of 1, and then what about the last one? Bounce. So it have an exponent of
2.
Good. All right. So now we got our factored form. We just need the a value. So I'm going to use my y-intercept again. I'm just going to guesstimate. Let's say this is at 0.30. All right. So if I set this up, I have 30 is equal to a times 0 plus 1 times 0 minus 2 times 0 minus 4 all squared. So this would be 30 is equal to a times 1 times -2 times, what's 0 minus 4? -4. What's -4 squared? Positive 16. Good. So this would be 30 is equal to 1 times -2 is -2 times 16 is -32. Divide both sides by -32. I get 30 over -32 is equal to a. Now, what would that fraction simplify down to? What's the number I can divide into the top and the bottom? 2. So if I divide the top and the bottom by 2, I get -15 over 16 as my a value. So does that fit the notion that my a value is negative? Yes, so that goes along with the graph. Now, we know it's an even graph, so there needs to be an even number of roots. Is that true? So if we count the factors, how many factors do we technically have? 4. Because remember, 1, 2, count this one twice. 3, 4. All right. So since it's even, we're good. Any questions on the graph side of this? You guys okay with it? So do I need to do another one, or are you okay? Okay, I'll do one more. I'm just going to get the factors, okay, and the end behavior. So we're not going to worry about solving for A. I'm pretty sure y'all are okay with that. Okay. So first off, Mackenzie, based off of my end behaviors, it's going to be even function or odd function. Even, because both tails are facing the same direction. And would they be a positive or negative? Positive, because they're going up. So this is a positive even. My roots are -3, 1, and 4. So if I write the factors, okay, remember, you just write it as x, and then you switch the sign of the root. So this will be x plus 3, x minus 1, x minus 4. All I did was take these roots, flip the signs. All right, so Tyreek, what's my dance move for -3?
Bounce.
It's a bounce, so what would the exponent be? 2. What about for -1? Not -1, +1.
Wiggle.
Wiggle. So if you look, it kind of looks like a cubic function. You drew it. So that's a wiggle. So if you have an exponent of what?
1.
So it's cubic.
3.
So cubic has 3.
3.
And x minus 4 is?
Cross.
It has 1. And that'll give you your factors at the very least. And if you counted them, this is 1, 2, 3, 4, 5, 6. So 6 factors total, even. All right. Any other questions on this part? All right. So let's look at the next part. So the next part comes from the real and imaginary roots. Okay. Every polynomial has a combination of real or imaginary. They're either all real, all imaginary, or a mixture of both. All right. Now, it's very easy to figure it out because the real roots are the ones that we automatically see. The real roots are the ones that actually cross through the x-axis. All right. Now, it's easy to figure out how many imaginary there are because all you do is take the number of real roots plus the number of imaginary, and that equals your total number of roots. And remember, the total number of roots comes from the degree of your function. So does anyone remember what degree means? We talked about this earlier in this unit. What does degree mean? Or what gives us our degree?
Exponent of the biggest coefficient. Like the biggest coefficient, I think.
So it's not the coefficient, but you're right about the exponent part. But what about the exponent? It's the biggest exponent. So, highest exponent. That's what gives us our degree. It also gives us the number of roots. All right. Now, another thing to note is that imaginary roots come in pairs, meaning each imaginary root is comes in a set of 2. And that accounts for the plus minus. All right, so typically when we see imaginary, so it has that I, there's a plus minus in there. So it counts for the positive version and the negative version. So it comes in pairs of 2. So let's just look at this. So it's hard to see, but here's my x-axis right here. First off, what's the degree? Let's go with Peyton. What's the degree of this function? So if we look up here, what's the highest exponent? 2. So our degree is 2. So that means our total number of roots should be what, Peyton? 2. All right. So Peyton, pick someone and tell me the number of real roots. All right. So Layla, how many real roots do I have? So how many times does that graph cross the x-axis? It doesn't. So I have 0 real roots. So Layla, if I have 0 real roots and I'm supposed to have 2 total, how many imaginary do I have? 2. That makes sense, guys? All right. We'll just do one more for good measure. Look at number 3. So again, it's hard to see, but the x-axis is right here. So Layla, pick someone to tell me what the degree is. All right, Julian, what's my degree of number 3? 4. So that means how many total roots do I have? 4. All right, pick someone to tell me how many real I have. So, Caden, how many real roots do I have? In other words, how many times does it cross the x-axis? So the pink line, Caden, how many times does the graph go through it? There's one here. Does it go through the line again? So you got 1. Is there another one?
2.
Right here. So that means we have 2 real roots. So, Caden, if we have 2 real and we're supposed to have 4 total, how many imaginary?
6.
We have 4 total. So if we have 2 of them are real.
2. Okay, 2.
There you go. It's okay, guys. It's a Wednesday. All right. Any questions on this? Pretty straightforward. All right. Now, next thing we got to talk about is the additional roots. So, something you got to notice is radical roots and imaginary roots always come in pairs. So, if your root contains a radical or an imaginary number, so a radical symbol or an I, they come in pairs, meaning there should be a positive version and a negative version because the 2 comes from the plus minuses. All right, so for example, if I broke apart this one, this would be 3i and negative 3i. If I broke apart this one, it'll be 5 plus square root 2, 5 minus square root 2. All right, so what this is going to show us is they're going to give us some of the roots, and we got to make sure that all of them are represented. So again, if it has an I in it or a radical in it, so a square root symbol, we got to make sure that the positive version of it and the negative version of it is there. If it's not, we need to add it. Then we're going to figure out what the least degree is, meaning if we have these roots, what would have to be at least the lowest degree of the function? It's not the exact degree per se, because we don't account for the dance moves yet, but it'll give us an idea. All right. So let's look at letter A. So the 2 roots they gave me were 1 and 2 minus the square root of 5. So first thing you gotta ask yourself, do I have a radical or an I in any of my roots? Yes or no? Yes. Which one? 2 minus the square root of 5. Do I have both the negative and positive version of that? No. So in other words, if I look in front of the square root specifically, is there a negative and a positive version? No. So what root am I missing? So how would I write it? Good. And I put parentheses around it just so I know that it's all one root. All right. So how many roots do I have total? So including the one that we just came up with, how many do I have total? 3. So what do you think my degree would be? 3. All right. Does that make sense, guys? Pretty straightforward. So just to make sure we're good, look at letter B. So letter B, we have 2, 3, and 4i as our roots. Do I have an imaginary or a radical in there?
Yes.
Yes, I have an imaginary. Is the positive and negative version represented? No, just the positive. So I'm missing what? Negative what? Negative 4i. So how many roots do I have total, including the one we just came up with? 4. 1, 2, 3, 4. All right, last one because of this word right here, multiplicity of 2. Does anyone remember? I did tell you guys about this. Does anyone remember what multiplicity of 2 means? What do we have to do with the root? I'll give you a hint. It's the same thing as if you squared that root.
Multiply by itself.
No, it's the same thing as if you squared the factor, I should say. So in the previous one, we came up with the factors and we had 2. It was squared. One of the factors was squared. It's like x plus 1 all squared. What do we have to do with that factor? We were trying to figure out the degree. We had to count it twice. Good. So multiplicity of 2 just simply means count the root twice. So multiplicity of 3, count it 3 times. Multiplicity of 4, count it 4 times. All right. So 5, the root of 5, we're going to count twice when we figure out the degree. All right. But first we need to figure out we have an additional root. We do have an imaginary number. We only have the positive version of it. So what is my additional root that I need? -2 minus I. So if I count all of the roots, how many do I have? Make sure you count the 5 twice. 4. 1, 2, because I have to count the 5 twice. 3, 4. All right. Yeah. All right. Any questions on that? Now, we're doing all of this because now we're going to go into the big honcho. Okay. This is where we are doing everything. I do mean everything. So, look at the next page. Now we're doing the main idea of what we were going to do today, which is finding all the roots and the factors. So, this is kind of a process, and it involves everything. So, before we do anything, you do need Desmos, so go ahead and take your Chromebook out. I'm going to switch the Go Guardian so it automatically opens up to Desmos for you. It should be the testing version. So guys, remember, in the testing version, it should automatically open up when you open up the internet. Make sure you select NC, like hit choose assessment, select North Carolina. Make sure the graphing calculator is highlighted, hit start practice. So while you guys are pulling up Desmos, just listen. Okay. So when we are finding all the roots, and that includes the ones that are real, the ones that are integers, the ones that are radicals, the ones that are imaginary. This is why I made you guys practice a lot of quadratic formula yesterday. First thing you would do is you graph the function in Desmos, and you find all of the integer roots, meaning they're nice numbers, so 2, 3, -4, -5, whatever. All right. So we put it in graphing calculator, and you can check with either the graph or the table. Typically, if it's in Desmos, you can just click on it. It's there. All right. Then we write out the corresponding factor for each of the integer roots. I don't know why it says integral. It should say integer. Then, once we get all of our integer roots, we use them to do either synthetic or long division to reduce the polynomial by dividing by each factor one time. So in other words, the goal is to get our original down to a quadratic. All right. So if it's a cubic function, we'll have to do the division once because there would be hopefully at least one real root. If it is a quartic, meaning 3 or 4, we'd have to do it at least twice. So we're hoping there's at least 2 real roots to get it down to a quadratic. All right. Now, once you have that quadratic, heads up, guys. Once you have that quadratic, we need to find the imaginary and rational roots, and that's through quadratic formula. All right. Finally, we put it in the factored form and list the roots. All right. So this is a process. It's going to be a long process, so prepare yourself. We're only going to do 2 of these. Okay, that's it. All right. And honestly, on your test, you're probably only going to see like 1 or 2 of them. So follow along with the process. It's not necessarily hard because we've done everything before already. There's really nothing new here. It's just kind of making sure you're putting it all together. All right. So let's look at letter A. What I want you to do first is put this function in Desmos and tell me the number of real roots. So take a minute, put it into Desmos, figure out what the real root is. So however many real roots there are, click on them, make sure they're nice numbers. I only want to know the ones that are nice numbers. If it's not a nice number, it's probably a radical root. So it's like something with a weird decimal. It's probably radical. After doing all right, thumbs up if you're ready. All right, what is my root or roots, Lainey? Just 2. All right, there's only 1, and it's 2. All right, so that's our only real root. All right, it only crosses the x-axis 1 time. Now, the next thing we're going to do is we're going to use that 2 as our root, and we're going to use to divide into here. Now, I'll let you decide. Do you want long division or synthetic? Okay. I'm going to do synthetic, but then I'll do long for some of the other. Okay. So, honestly, synthetics is the easier one, but okay. All right. So, how would I set up synthetic? So, I got the 2 in the box, and then Lainey, pick someone to tell me how to set up the rest. So, Leslie, what do I have to write across the top? So, in other words, the what? Coefficients. We take all of our coefficients, and remember, we got to make sure that all of the exponents are represented from 3 to 0, which they are 3, 2, 1, 0.
So why is 2 our root when this?
So you were at the back for this, but I had them put it in Desmos, and they actually clicked on it.
Oh,
So yeah, that's your first step. You put it in Desmos, get at least 1 real root.
okay.
Yes. No. So because we already have the root, not the factor, it stays the way it is. All right. Now, if we were given the factor first, like if it was x minus 2, then we would switch it to 2. All right. But remember, this is just the root. This is the root. Okay. Now, I'm going to draw the line so I know where my remainder is. Now, if we know that 2 is a factor, that means our remainder should be what? So we know that 2, or x minus 2, is a factor of our original. So our remainder should be what? When we finish. So it should go evenly. So that means our remainder should be what? So guys, 25 can be divided by 5 evenly. What's the remainder?
0.
0. So if we don't get a remainder of 0 at the end, we did something wrong. Okay? So Leslie, you were the last to talk. Pick someone to tell me my first step. Which one? All right. Dylan, no. First step.
Drop the 5 down.
Uh-huh. Then what do I do?
Multiply by 2.
Uh-huh. Get.
10.
Then.
Add. Get 1.
Good. Pick someone else.
1.
You times it by 2 and then just do something.
So times by 2 and get.
2.
Then
You got it.
to get.
10.
All right. Pick someone else. Probably someone hasn't talked much today.
Frank.
All right. Frederick was my last step.
Multiply by 2.
Uh-huh. Get.
20.
Does that give us a remainder of 0? Yes. All right. So we got the coefficients now. Now, Frederick, pick someone to tell me what my new degree of the function should be.
Caden.
So, Caden, these are our coefficients and this is our remainder. All right. Now I need to figure out what exponent the first variable should have. So the one that goes with the 5. What do you think it would be?
3.
So not 3, because remember we're dividing, so we should be losing an x somewhere. So it should be, what's 3 minus 1? 2. So remember, you take the highest exponent and you subtract it by 1, and that's the exponent of your first one. So this should be 5x squared. And if we go down the line in terms of exponents, Kaden, what's your next one? So what variable goes with the 1? So after 2, we go down 1. So we have x with the variable 1, which is just x. So plus x. And then we need to have 1 with 0. So that's just our
What did you say? Sorry.
So now we got 5x squared plus x. How do we write the 10? So we covered 2 and 1. What does that leave us with? 0.
Yeah.
So if we have x to the 0 power, that turns into 1. Well, what's 1 times 10?
10.
So plus 10. Now, we got it down to a quadratic. So now we're going to do the quadratic formula. All right, so Kaden, pick someone to tell me what A, B, and C is.
Oh, no, there you go.
All right, so what's A, B, and C, Dylan?
A is 5, B is 1, and C is 10.
All right, so pick someone to help me put it into the formula.
I think I see that. I need to go again. So x equals -10
Okay.
plus or minus
Uh-huh.
10 squared, or the square root of 10 squared
Uh-huh.
minus 4
Uh-huh.
times 5
Uh-huh.
times 1,
Uh-huh.
and put that over 2 times 5.
Good. So I just put it straight into my formula. No simplifying yet. So Frederick, pick someone to tell me how to simplify.
Tyree.
All right, so Tyree,
Yes?
if I do right here, all right, what's 10 squared?
100.
All right, what's 4 times 5?
Well, that would be -20.
Okay, times 1,
-20.
what's 100 minus 20?
80.
So this would be -10 plus or minus square root of 80. Hold up.
I think you put the C in instead of B.
I did. So that's 50 times 4. So that would be -100.
Should it not? Because you did -10 plus or minus. I thought that's B. Why did you put C in?
Because I screwed up. Yeah, it should be 1. Oh my gosh, I'm all kinds of screwing up today. Okay, yeah. I thought that looked wrong. So this is negative 199. All over 10. All right, so Tyreek, since we have a negative under the radical, what do we have to do with it?
Multiply I. Take out the I.
Take out the I. Good. So it's negative, it's angry, we're taking that I out. So this would be negative 10 plus or minus I, square root of 199, all over 10. Now, your next step would have been to check to see if 199, you can simplify it any. You can't, it's prime. Yes.
C would be 1, not 10.
Yeah.
In the square root. If I do negative 4, not 5 times 1.
No, it's times 10. A's 5, B's 1, C's 10. I screwed up. I wrote the wrong thing. I screwed up. So you're good. All right. So 199 is actually prime, so we can't simplify it any further. So this is our 2 imaginary roots. So our last step, or 2 steps really, is to write the factor form and write out the roots. Let's write out the roots first because that's the easiest. And we're going to include the one that we found by graphing. So my first root would be what? What do you guys think? My first root. What's the very first one that we found? 2. And then my second and third would be negative 10 plus I square root 199 over 10. And then negative 10 minus I square root of 199 over 10. Son of a biscuit work. Yeah.
Also, wouldn't that be negative 1 and negative 10? That's B.
The negative 10 on the plus or minus should be 1.
You know, you're right. You're right. At least that's easy to deal with.
You okay with work?
No, I'm not, apparently. All right, so factor form. What is this? When Peyton gets back. So, what is 2 as a factor? So the root of 2, what is it as a factor? X minus 2. Now, here's the great thing. We're not going to write the 2 imaginary roots as like a weird factor. We technically already found the other factor. And it's our quadratic graph right here. So this quadratic that we found, because it gives us imaginary roots, this is our other factor. And we just write it verbatim. So this will be times 5x squared plus x plus 10. And that's it. All right. Any questions on that? Okay. We're going to do one more. I promise it's the last one. I just want to make sure that because the next one, we're going to have to do this division 3 times. Okay. So look at letter B. Now, there is a typo here. This 14x squared should be positive. So go ahead and graph that in Desmos and get all of the nice roots. So remember, the 14x squared needs to be positive, otherwise you're going to get some funky roots. It's a typo. So check every root that comes up. Make sure they're nice numbers. If they're not, you can leave it out. Thumbs up if you're ready. All right, so you should have gotten 3 roots. What are those 3 roots still in P? So there should be 3 zeros. Remember, the 14 has to be positive. Okay. Did you forget to make the 14 positive? So just switch the sign real quick.
-3, -1, and 1.
All right, so these are our 3 roots. So since there are 3 roots, we got to get this quintic function down to a quadratic. So we have to do synthetic 3 times. All right? This is where learning synthetic is a little bit easier than long division, because long division 3 times is, you can do it, it's just a pain. So it doesn't matter which root we use first. We can do any order of those 3 roots. We just have to only use them once. Okay? So I'm going to just do the order that we have currently. So I'm going to start with -3 as my first root. So Caden, what would I write across the top? What numbers would I write across the top? So what numbers would I write here for my synthetic?
-3, -1.
Well, we got the roots, but the numbers, remember, come from this function.
So x over 5.
So we only need numbers.
Okay, 2x.
So coefficients in front of them. What's the coefficient for the first one?
2.
Here.
1.
1. Okay, so 1 is the first coefficient. There's nothing there in front of it. It's not Mac 1. What's the next one? Then,
2.
not just 2, but -2, then,
1.
good. Now, are you guys pretty solid on synthetic, or do I need to go slow with this? All right, so I'm going to drop the 1, multiply it by -3. I get -3. Add them together. I get -2. Repeat the process. Multiply by -3. I get +6. Add them together. I get 4. Repeat. Multiply by -3. I get -12. Add them together. I get 2. Repeat. Multiply by -3. I get -6. Add them together. I get -5. Repeat. Multiply by -3. I get +15. Add them together. I get 0. Since I have a remainder of 0, I did it right. All right. Now, Tyreek, what would be the exponent of my first variable for my new set of coefficients?
4.
4. Good. Subtract 1 from the highest. That's your new. So this would be x to the 4th minus 2x cubed plus 4x or squared plus 2x minus 5. Now, we're now going to do synthetic again, but we're going to use our new function. All right, so I'm going to use the -1 root. So what would go across the top, Wyatt? Okay, well, just look at what I have on the board real quick. What do I write across the top for the synthetic?
1.
1, then,
-2.
uh-huh,
4.
uh-huh,
2.
uh-huh.
-1.
Good. Draw my line. There we go. And since it's a factor, our remainder should be what? 0. So again, if it helps to remind you, go ahead and write the 0 in as the remainder to make sure that you should have a remainder of 0. If you don't, You did something wrong. Okay? Yes, ma'am. Yep. All right. So, I'm going to drop the 1. Multiply it by negative 1. Get negative 1. What's negative 2 plus negative 1? Negative 3. Repeat. Multiply by negative 1. I get 3. What's 4 plus 3? 7. Repeat. Multiply by negative 1. Get negative 7. Right. 2 plus negative 7 is negative 5. Multiply by negative 1, I get positive 5. Negative 5 plus 5 is 0. Does everyone understand what I'm doing? Okay. So, what would my starting exponent be, Peyton? So, for my new function, all right, if we started with x to the 4th, what would the highest exponent be for our new one? Not 4. So, remember, you subtract 1. Right. So, it'd be x cubed. So, we now have x cubed minus 3x squared plus 7x minus 5. Now, still not at a quadratic yet, and we have one more root to go. So, we're going to use the cubic. We're going to do synthetic one more time with our last remaining root. Heads up, guys. Come on. Come on, sleepy babies. Heads up. We're almost done. So, I'm going to use my last remaining root, which is the 1. What is going across the top, Leslie? Good. And we know our remainder has to be 0, so I'm going to go ahead and put it there. I'm going to drop the 1. Multiply by 1, I get 1. Negative 3 plus 1, negative 2. Multiply by 1, I get negative 2. 7 minus 2, 5. Multiply by 1, I get 5. Negative 5 plus 5, 0. And we're done. And then what is my highest exponent for my new function, Jordan? So we start with x cubed originally, so what's the new one? X squared. So it's be x squared minus 2x plus 5. So this is not only our quadratic, it'll also be one of our factors. All right, so just kind of make a note that's also going to be one of your factors. Because we know we're going to have at least 2 imaginary roots because we got 3 real ones. So now we're in quadratic formula. Yay, we're almost done. So ABC, what is it, Mackenzie? Uh-huh. Uh-huh. 5. Good. So I can trust that y'all can put it in the formula correctly or for the most part. So I'm just going to kind of breeze through that part. Is that enough? Yep. So I have negative b, so negative times negative 2, plus or minus the square root of negative 2 all squared, minus 4 times 1 times 5, all over 2 times 1. I just put it in the formula. No simplification, yes. When Layla gets back. Now, for simplifying, I'm going to simplify the 2 negatives. So negative times a negative, that gives me positive 2. Now, what goes under the radical? Negative 2 squared is 4. Negative 4 times 1 is negative 4 times 5 is 20. So 4 minus 20 is negative 16. All over 2 times 1, which is 2. Now, since we got a negative under that radical, Frederick, what do we have to do with it? So we got a negative under the radical. It's mad at us. It wants to get some aggression out, so it does what? Takes the I out. Good. This would be 2 plus or minus I square root 16 all over 2. And what's the square root of 16, Ryan? Good. So this will be 2 plus minus 4I all over 2. Now, I still need to simplify these three numbers. What's the number that can go into all three? 2. Divide them all by 2. 2 divided by 2 is 1, plus or minus. 4 divided by 2 is 2, so 2I all over 1, so we don't have to write that. So this is my imaginary, so my two imaginary roots. So after all that hullabaloo, when I write out all my roots, I'm writing out all of them, including the ones that we started with. So I have -3, -1, 1, then 1 plus 2I, and 1 minus 2I. I should have 5 roots total, and I do. 1, 2, 3, 4, 5. Now, what is -3 as a factor, Dylan L? X plus 3. What is -1 as a factor? Bathroom. Julian. X plus 1. And what is the last one? Crap. Let's go Mackenzie. Right. Now, what's the only root that we're missing? So this is the one. Right. So what do I use to represent the imaginary ones? We use the what? We use the quadratic that we got after we did all the division. All right, that represents our two imaginary roots. So this will be x squared minus 2x plus 5. So, like I said, it's a lot, it's a pain, but you're only going to get like 1 or 2 of those on your test at best. You still need to know how to do it, though. Yes?
If you do the -3 root, shouldn't there be a 5 in the first?
Say it again.
Where did you get the 1 for the first one? Shouldn't it be 5?
The one like for the start? Oh, it's the coefficients. So we use the coefficients. All right, any questions on any of this? All right, yes, sir. Just go. Okay, so for the rest of class, because you have a solid 15 minutes left, there is a delta math, 3.4 and 3.5. It's all in one delta math, so it covers what we learned yesterday and what we talked about today. So you guys should be able to knock out at least a little bit of it. All right, so go ahead and get started on that. Hold on, I know I gotta unblock it. Give me a second.